Oh my goodness. It is another day here in paradise. I say that as I am getting ready to come on back to you all live here. And, hey, it's good to be here. I've missed y'all, and going live again like this, saying hello to everybody, actually clicking the go live button this time. Naturally, it's not perfect because I forgot to close my curtain. Hold on. A snowy paradise in Colorado, says Charles. That's excellent. Good to see you, Charles, by the way. Hope you're doing well. So this is a bit strange. If you are a former student of mine, this is very strange. So, Charles, this is very strange for you. Believe it or not, a long time ago, I lived a different life. It was a very different life. And that life was... I played games professionally. I was a professional video game content creator. It was a good time. It's where I learned how to do things like streaming and broadcasting and putting together a program and getting the lighting just right and all that fun stuff. It was a good time. It was a very good time. In any particular case, I took those skills, combined them with my IT skills, and said, darn it, let's put together some good educating programming. And today is sort of the culmination of a lot of different efforts, because we've released a really cool new thing here with Alta 3, and we're going to talk about that today because I wish this existed a long time ago, but we've built it, and we're really excited about it. So this here is the Kubernetes Coffee and Games podcast, where we talk all things Kubernetes, coffee, and games. Oh my goodness, that was a weird cut to an ad there. We'll just close out of that. In any particular case, we're going to be spending a lot of time talking about the Alta 3 Academy, which is an all-access pass to pretty much any tech, DevOps, mastery, certification, whatever you'd like to get into. That's your ticket. And if there's ever been a zero to hero program that is, one, affordable, approachable, it's this one. We'll talk about it, what it is that you get, and what you can expect from some of the course materials that will be provided to you. So before we get started into that, though, I do want to put out a quick shout out to our friends over at Alta 3 for allowing us to use their infrastructure today to continue our free lessons. And I wanted to kind of jump into an introduction to Linux today. I wanted to jump into an introduction to Linux because the last couple of episodes, we were deep diving into containers, and we were deep diving into Kubernetes, how to write pods, and what is a pod, and sort of the technical minutia of orchestrating containerized workloads on Kubernetes. But much of my audience, that was a bit over their head. And so I decided, well, hey, now wait a minute. Why don't I start with something basic? Why don't we do something simple? Why don't we do something like, what is Linux? What is an operating system? What is a kernel? What is basic Linux commands? Because the truth is that a lot of people are interested in IT, DevOps, that sort of stuff. But they start seeing me plug around in Kubernetes, get super intimidated, like, wow, that's really hard stuff. It's not. One of the greatest mysteries of this world, to me at least, has been, how do we convince people that something that is so trivial, so easy, isn't the most complicated thing on the face of the planet? As a lot of people see us play around in command line, their brain immediately shuts down. If you're an older fella like me, oh my gosh, I'm not that old. I'm coming up on 40, though, this year. Anyways, point is, you probably have seen MS-DOS. And it's one of those old school terminal-based operating systems, and you might view it as something that's archaic, old. And you don't realize it's the best user interface ever developed on the face of the planet. And it's a powerful tool. And so instead of learning it, a lot of people just go, well, that's old. Show me where all the buttons are. I'll click those. We're going to talk about this. We're going to talk about why Linux. We're going to talk about why it's important that you learn a command line interface like Linux, and how to navigate POSIX, or a file system, in order to begin working on developing, again, everything from web services to CI/CD pipelines to your own applications and web services, the whole nine. And so that's what we're going to get into today as far as our learning exercises. And I'm really excited about that. Deep Squid, good to see you, man. Listening while working, so I'll be lurking around. No problem, Deep Squid. I think we've talked before about you wanting to learn some IT. This is the episode for you. We're going to get into the basics. So with that being said, that's what you can look forward to today. We're going to be doing Alta 3 Academy, and we're going to be doing Why Linux? Why do I need to learn Linux? And some basic things about how computers function. So we're going to kind of pull from my brain hole, and we're going to discuss these really cool. Yes, it's the root of it all. Exactly. See, Deep Squid, you're ready. You're ready, man. I'm excited. Let's get into Alta 3 Academy, because here's the deal. This is the best darn thing since sliced bread. I literally called up Stu this morning. Stu is the owner of Alta 3 Research. He's Stu Fieser, or Stuart Fieser, and everything that we do runs out of his basement. It's all powered by equipment in his basement. And we got some of the smartest technical minds on the face of the planet, and we put them together, and we said, how can we make everybody else smarter? And what we did was we came out with classes. Now, these classes were super expensive. For a week's worth of training, you're spending $2,500. Yikes. But that's 8 hours a day in a learning environment with a fully curated course with an instructor. That's intense level training. Yeah, it's expensive. But for the average person, that's way too expensive, because it's not just the $2,500 to take the class, because now you have to give 40 hours of your life to the class. That's 40 hours where you could be making money, 40 hours for working a job, for collecting income. And if you're an individual and you want to pay for that course, that means you're going to take a week worth of vacation to then work 40 hours? I don't think so. People don't do that. Now, Charles is correct. That's typical cost. $2,500 is about right. $2,200 to $2,500. That is comparatively, and even in many cases, competitively priced, depending upon what you're talking about. Because if you get into Red Hat Enterprise Linux and you're doing RHCSA training, that's $5,000 for a week of training. I don't know how they get away with that. That's highway robbery. Point is, we're flipping the script. Because the truth of the matter is that we live in a world where nowadays, if you're young and you're coming up, and let me tell you, all right, I've been doing foster care now for almost a year, and I've worked with a couple of youngins. Self-paced learning, man, that's what they're all about. They don't want to interact with an instructor, but hey, I'm here anyways. Point is, learning how to use the internet, learning how to read, learning how to use basic tech skills, suddenly you're equipping yourself with the ability to learn whatever it is that you want. And people don't want to spend $2,500, nor do they want to schedule a whole week's worth of classes and then take a week of vacation to learn something. No one wants to do that. That's unapproachable. It's not going to work. So how do we solve the problem? Here's how you do it. Alta 3 Academy, this is an all-access pass to DevOps Mastery and Certification Success, which is the fun little blurb that you have here. Here's the blurb I'm going to give you. You get 14 classes. You can approach them whenever you want. You have full, unadulterated access to virtual learning environments that you could just turn on real nice and easy and turn off whenever you're done with it. So you have access to now hardware that you don't have access to currently. Real nicely, easily set up for you. And you could begin running the labs and the exercises on those machines for a simple subscription price. And when I tell you this price, it's a $3 trial, y'all. Okay? You're silly not to try this. $3 is the trial. Very easy to cancel it. Okay? This is cheap. This is ridiculous. So what you're going to end up getting, and there's a bunch of videos here. Let me put a link to you in the chat. If you want to watch the videos, you can go ahead and watch the videos. You can do your thing there, right? But the whole point is that we can get you CKA certified. We can get you CCAD certified. We can get you Terraform associate. We can get your Python and Ansible automation certifications, so your PCEPs, right? All that good stuff. And these are just 9 classes. I got the full list this morning, and I'll share the full list with you all here in a second. But these are the 9 featured classes. Crush the RHCSA. If you're getting ready for getting Red Hat certified, some type of Linux certification should be in your future if you are approaching this this industry. So if you're someone looking to make a change, or maybe you're someone looking to prove your skills, getting an RHCSA is a really, really good idea. That's typically where I tell you to begin. Knowing your way around Linux is probably one of the most important things you could ever learn in this industry. Just do it. Then you have Certified Kubernetes Administrator, CKA, which is a class that I teach, and I teach those for 5 days in a row, 8 hours a day. Charles knows because he went through my course not too long ago. And then we have a Certified Kubernetes Application Developer course, which is based on more for people who are developing software that is going to be supported or run on a Kubernetes platform. And then we have a CKA mock exam. That's brand new. And a CCAD mock exam. Ansible Essentials is a big one. Infrastructure as code. Basically, this is your ability to set a desired state and have a playbook, play-by-play, task-by-task approach to scripting for configuring infrastructure, installing applications, and making everything in the appropriate state. We could do that idempotently with Ansible. Huge, you need it. Python, even if you are not a computer programmer and that's not what you're into, you're going to need to know Python essentials, especially if you're a systems engineer, if you're a network engineer, if you're doing anything with artificial intelligence, you will need to know Python. It is a necessary, mandatory skill for so many different career paths. Just learn it. It's really easy. Think about Python in terms of forms. That's all it is. It's a form. And you're just filling out a form. Every function is a form. And then you order the forms, and then you create your own forms, and it's good stuff. It's really not that hard. I am saying this because I, for the longest time, was super intimidated by pretty much any kind of coding, period. I didn't want to learn it. I was really resistant to it. I hated it. Didn't want to think about it. Now I love it. And I don't know why I didn't get into it sooner. It took me forever to get into it, and that was bad. So learn from my mistake. Jump into Python, and the big reason why I'm going to tell you jump into Python is this: API design. Building your own APIs, and then learning how to access APIs, publicly available APIs. Wow, that's good stuff. There's a lot of people who build entire tools and make good living off of accessing someone else's API and just providing information to you, the end user, in a way that's digestible, easily queryable, and the whole nine. Easy stuff, nothing too terribly difficult. Working with Flask and RESTful APIs, authentication, the whole nine. It's good stuff. Take a look at API design with Python. That's a great course. And then Terraform infrastructure as code. This is another way in which we can build appropriate state-managed configurations and applications. Big thing, though, is that we want to provision hardware, right? So Terraform is all about placing an order. I want this many machines. I need these machines to have these configurations. And you can call a Terraform config with an Ansible playbook and vice versa. It's really cool. If you're learning infrastructure as code, if you're learning Ansible, you should also learn Terraform. The two work hand in hand, and the systems that you could build and provision with that combination of knowledge, otherwise known as the quote-unquote terrible stack. Terraform, Ansible, terrible. It's the terrible stack. It's not bad. It's good. Take a look at it. You definitely learn it. So here's the pricing. Here's the brass tacks. And Charles, you purchased training for your organization. This is absurd. When I tell you this is just the dumbest, best deal on the face of the planet for learning IT, making your career change, sharpening your skills, or maybe exploring something in our industry that you haven't looked into yet, this does not get better. $299 for a whole year. And I want you to think about what that is. It's a subscription, but it's $299 for the whole year, where you can provision an environment on demand whenever you want. You can run through all 14 courses as many times as you want. You can take all the practice exams as much as you want. This is one of the most ridiculous products on the face of the planet in terms of learning IT. I had a conversation with Stu this morning. I think I was alluding to this. I didn't finish the story. I told him that people are robbing him blind with this deal. I did. I literally said, you are stupid not to take this deal. If you're someone who wants to learn IT and you're looking at this, this is ridiculously cheap. This is ridiculously cheap. You've got to jump on this. I don't know how long the pricing is going to be like this. As one of the questions I asked you this morning was, how are you going to scale this? Because if word gets out, because right now Alta 3 Research is a best kept secret. No one knows anything really too much about this. Is not a brand that is recognized at home. It's a best kept secret. The best training on the planet with the best instructors. I don't say that lightly. I've been to many trainings, and okay. Point is, so we're the ones delivering this content, and you're going to get it all for $300 a year. That's wild. That's incredibly cheap for 14 courses. Now, the whole course list, I'm going to post this in the chat. I'm going to read it for those who are going to be watching or listening. So you know all of the, okay, apparently that was too much. That was too much for the chat to handle. So maybe what I need to do is I'm going to put this up on a notepad, and then I'll show it to you that way. How about I do that? That works. Wonderful. And that'll do it. Here's the whole list. 5G Essentials. Introduction to Ansible. Network automation with Ansible. Building API clients and servers with Python. The Certified Kubernetes Administrator. Certified Kubernetes Application Developer. Crush the CKA mock exam. Crush the CCAD mock exam. Crush the RHCSA EX200 mock exam. An introduction to Python. Network automation with Python. Session Initiation Protocol, otherwise known as SIP Essentials, Terraform Essentials, and VO LTE and the IMS. Some really cool stuff here if you're into 5G or telecommunications, SIP, and I don't know what this is. I'll be honest with you. That's not my wheelhouse. It's definitely in telecom. But those are the full 14 classes. Now, here's the cool thing. You guys ready for this? Because this is where things get truly, absolutely, ridiculously nuts. You ready? We're going to add more classes. This is just the initial offering. So the idea is that here's 14 classes you could take whenever on the appropriate hardware for whatever class it is that you're taking. It's good to go, fully curated, all with video content. So there's video lectures, so you can watch a lecture from the instructor, and you can see the course, and you could run through the labs and perform everything that you're supposed to perform. It's great, okay? You get all of that, and then we're just going to add more. So it's 14 classes today, and as time goes on, we'll be adding more and more and more courses. So it's a subscription that just keeps getting better. This is, as I mentioned before, one of the most ridiculous things I have ever seen. I am super confused as to how and or why this is happening. But the point is, this is a good deal. So any of the demos that I am running, whenever you see me run this podcast, which is something that I want to do more regularly, especially now that we have Alta 3 Academy up and running, because now if you want to learn along with me and you want to run what I'm running, because I run stuff that's not on the courses, I'll do stuff that's not a part of our courses. You want to explore something, tackle something, you want to learn something new, or you want to pick my brain, I can build labs on the fly. I literally can. I can build a lab in real time and run it. That's not a problem. But you can do that along with me using the appropriate environment and infrastructure with this subscription. So for $3, $1 a day, you can gain access to Alta 3 Academy. That's nuts. Try it out. Get a free trial. And if you go, hey, this is pretty dope, you can get a monthly subscription or an annual subscription. And I'm telling you right now, $300 for all that content is ridiculous. My hope is that you get into those environments, we can make this a regular thing. I'm in talks with Stu. I said, Stu, I want to be a reseller. I want to like open up my own sort of like training academy, and we're going to be reselling your environments. And I want to be able to do this on an abnormal schedule with non-traditional course offerings. Because the average Joe who needs to learn this stuff, they cannot commit 40 hours a week at $2,500 to do it. It's impossible. Well, you know what they can do while they're driving their truck down the road? Deep Squid, I'm thinking about you. Is they can listen to me on the podcast. They can participate on the labs on their own time. And then they can come back and ask me questions. And they can learn through non-traditional means. This gives me the ability to resell Alta 3 content to people in my local community, which is huge. So this is a full game changer, considering how accessible and how easy this training is to get onto. It's ridiculous. As I said before, I said stupid. Stupid's not the word I wanted to use. You would be a fool not to jump onto this if you have any interest in learning IT. Okay? So definitely consider this. Think about it. Jump on it. Charles, thanks for hanging out, man. I'll see you later. Definitely consider doing this. This is for you. So there you have it. That's my sales pitch. Does anyone got any questions for me regarding Alta 3 Academy? Anything you need to know? And if the question is, do I need to have any prior knowledge before jumping into Alta 3 Academy? The answer is no. But what prior knowledge you would probably want to have, I will give today. I will teach a free lesson about basic Linux. What is a Linux operating system? What are the different types of Linux operating systems? We're going to jump into that. We're going to talk about that here in a little bit. So that way you're going to it with a little bit of an understanding of what it is we're jumping into and what's going on. Any questions? 1 second, guys. All right, perfect. All right. So, with all of that being said and done and out of the way, no questions came in, so I feel pretty good about it. What I want to go ahead and do now is I want to kind of kick in the podcast into a different direction briefly before we jump into our Linux lesson. So, the big thing that I have been trying to kind of communicate to everybody, now that I'm able to kind of talk more freely and be available on live streams more frequently, is that I have been doing this thing in my life. I've been raising children. It's scary. I know. The fact that a child could be raised by me is terrifying. The more terrifying thing about it is that these are not my own children. I've been doing foster care, and part of this foster care journey has been incredibly rewarding, but there are other parts that have been very challenging and very scary and very, very dreadfully concerning. And one of those involves a child who has been in my care and is currently not in my care, and we're fighting desperately to get her home. And the fact that there's even any type of legal battle about this is absurd. So without getting into too many details, because there's not so much that I can say due to confidentiality and privacy reasons, we are live streaming. I need to make sure that I stick to the script. And so what I want to do is just briefly share our GoFundMe, and then we're going to talk about a little bit of the problems that we're experiencing here in West Virginia regarding foster care and the whole nine. But what I want to do is I just want to just talk about this GoFundMe real quick and encourage you to support or share it. But this is about a girl who was in our care, who is in desperate need of legal representation. Her rights are actively being violated. She is currently in a state of great distress, and we need to get her home. We need to get her home and back in communicating with the people who love her, and we could really use your help. So here's the deal. Let's go ahead and let's read this. So help us fight for a child's right to safety and family. We're reaching out for support in an urgent legal battle to protect a vulnerable child who has been failed by the system. Now, this child, who was once in our care and remains deeply loved by our family, has suffered mistreatment, neglect, and unnecessary separation from those who care for her the most. From the moment she entered our lives, she made it clear she wanted to be part of our family. She calls us mom and dad and has repeatedly expressed her deep desire to belong with us permanently. Despite this, the system has ignored her wishes and placed barriers between us and her, denying her the stability, love, and security she deserves. Over the past year, we have fought tirelessly to ensure that she is safe, heard, and protected. Unfortunately, due to serious failures within the foster care system, she has endured documented abuse in placements that should have protected her. Despite overwhelming evidence, she was placed in harm's way, and now she has been cut off from us entirely without legal justification, which is a direct violation of her rights. We have secured legal representation and are taking action to challenge these decisions in court. And our goal is to restore her right to maintain safe, meaningful relationships with those who love and support her, to give her the opportunity to have her voice heard in court, hold accountable those who failed to protect her, and ensure she has a chance to grow up in a stable, loving home, one she has already chosen. Unfortunately, legal battles of this nature are costly. They are very expensive, and we cannot do this alone. Your donation to this GoFundMe page will help cover attorney fees and legal filings to fight for her right to family, expert testimony and court costs necessary to prove her case, and investigative resources to ensure her well-being is prioritized. Every dollar raised brings us one step closer to giving this child the home and future she longs for. If you believe that every child deserves safety, love, and a voice in their own future, please consider donating and sharing this campaign. Thank you for standing with us in this fight for what's right. Your support means everything. With gratitude, Timothy and Rebecca. That's me and Tanantha. And here's another picture of our daughter. And I wanted to let you know that we have been doing great. This particular GoFundMe has been doing tremendously well. We're really excited about it. Couldn't be happier. But in short, in just 3 days, we hit our original GoFundMe goal. Wow, that was wonderful. Now, that was approximately 50% of the estimated cost of what we'll need for the attorney and court fees. And we are prepared to fund the other 50%. However, that's coming out of our fund for housing upgrades, such as the computer lab and trips that we had planned for our currently placed children. So what this means is that any future support that we receive will allow us to keep our funds for things like summer vacations, computer lab, and other fun things we had planned for the kiddos staying in our home. So we could definitely still use the support. And thanks again for all that you've done and contributed, but our mission continues, and your opportunity to help all the children in our care still remains. So there you have it, everybody. Thanks for taking the time to listen to me talk about this. This is a very big deal. And it's not just about this one child. There are many children, particularly here in West Virginia, that do not have appropriate legal representation. And the reason why is because there are so many children here in West Virginia who are removed from their homes, who have had a termination of parental rights. The parents have lost rights to custody of their children for a number of different reasons. And these children are all alone. They don't have family. There's not enough adoptive families for these children, and they end up getting lost in the system. This happens time and time again. And you go, well, don't these kids have lawyers? Don't they have a guardian ad litem or something like that? Yes. Yes, they do. They do have lawyers. They do have a guardian ad litem. That is something that they have. Problem. There aren't enough. For every 200 kids in the system, there's one guardian ad litem. So what that means is that not every child is represented. And those who are represented, the guardian ad litem's attention is spread so many different ways, it's impossible for them to provide the appropriate care and attention that an individual child needs in court. And so what often happens is after there's a TPR, and the kids are fully in the custody of the state, the guardian ad litem is no longer representing the best interest of the child. And when their rights are violated, there's no one to defend them in court. And that's what's happening with this young lady. And that's the reason why we have to go out of our way with our own money and with money raised from y'all to help support her. So that is a bigger problem, and I'm hoping that over time I might be able to address this problem for more than just with our daughter, but with other children who are in need of this type of support and help as well. So thank you very much for taking the time to hear me out on this. And if you are at all interested in donating and or contributing to this GoFundMe, please, please, please consider it. This is very helpful for us and getting the representation that she needs. And we're very much looking forward to raising more funds so that way we can fully support this through the GoFundMe without any needs to cancel vacations or things for our other placements. So we're ready to do it if we need to, but in any particular case, that support is still going towards her. Thank you so much for the support you've given us, and thank you for sharing. Okay, everybody. Is there a way I can get a roll call? Who's here? We're ready to get into some training. We're going to learn some Linux. Normally we do a like spike. I hadn't asked for a like spike yet. Little Lord Sissy is here. Hello. I knew you were here. I knew you were here. You booped me earlier. You did. You booped me earlier, man. Which is crazy. Hope you're doing well. I've been listening. Welcome, man. Welcome. Welcome. Indeed. Indeed. Sounds like we got our hands full with stuff. Yes. Sure. Hands. Oh, hands. Yeah, we've been, little Lord. Yes, I have been very busy. All right. In the past, what we used to do is something called a like spike. Here's what a like spike is. You ready for this? You hit the like button. That tells YouTube that what we're doing here is fun and exciting. And then you type hashtag like spike because that also tells YouTube that what we're doing here is fun and exciting. And that gets the word out there because what we're about ready to do is we're going to jump into Linux. What is Linux? Why Linux? Why do you need to know and understand Linux? And why is that so important? Now, the next thing, before we jump on into this, is if you are an Alta 3 Academy subscriber, free trial only $3. You get 3 days, $3. You can follow along with me on the labs, and you can learn with me. So you can try out some different things. You can learn different Linux commands with me today, and it'll give you an opportunity to really jump on in and get your feet wet a little bit in terms of Linux. So definitely, if you're a subscriber, go ahead and load up an environment. A Python Basics environment would be perfectly fine, or the RHCSA environment. Once you are in with that subscribed content, you should be able to launch the appropriate environment for the course that you are taking. I would say RHCSA is probably to go because that is the Linux-based program. Load up an environment, and we're going to be getting into Linux. Now, the big question is, if you're new to this, all right, and I'm going to use a fun little tool of mine. It's the best tool on the face of the planet. I love it. I want to make sure I can explain this in a way that makes sense for anybody who doesn't know Linux, who doesn't already have some pre-existing knowledge. Okay? So I want to get some pointers. So, I love this. Yes, this will work. This will work. Excellent. Cool. Let's go ahead on into that's not what I want. None of this is what I wanted. What has happened? Oh, I know what happened. We're going to get rid of the... There we go. And I want that. There it is. All right, cool. Let me get the window size properly, and then we're off to the races. Excellent. I got to get a separate. Scene for the gaming side of the house. All right. In any particular case, let's get into this. So, when it comes to Linux, you have to understand that Linux is simply an operating system. Linux is an operating system. What's an operating system? Typically, people would say, well, it's like Windows or it's like Mac OS. It's what enables us to run the computer. It's sort of the user interface that you have. Well, I want you to think about it in terms of this analogy. So imagine that Linux is like a car. Excuse me. Let's backtrack. Imagine your computer. It's like a car. You have a car. And the operating system is the engine that sort of makes everything work. So you have all of this tech inside of your car. You have an engine, right? It's got wheels and axles and has a bunch of different pistons, and there's a combustion component to it. There's brakes involved. You got steering, right? And all the controls that you need in order to run the car. How the steering wheel moves, how the brakes respond, all of that is controlled by the tech built into the car. So Linux is the operating system, just like Windows or Mac OS, but there are some key differences between Linux and those other operating systems. So if the engine and all the tech built into your car, you can compare that to an operating system. It's what makes that machine operate. Linux is what makes your computer operate. It is the operating system. It's the engine. It's the tech built underneath the skids of the car. So we understand that Linux is an operating system, and Linux is what makes your computer tick, like any other OS, like Windows or Mac OS. So we use these all the time. But why is Linux so special? And why is it that all of the geeky computer guys, they like to use Linux, and we build our web services and other important services off of Linux-based operating systems? Well, the first thing is, this is the Why Linux, the commercial edition. We'll talk about Why Linux, the Tim edition, here in a minute. But the commercial edition of Why Linux is real nice and easy. You guys ready for this? It's free and open source. I don't know about y'all, but I like free. Free is great. Free is what we want. Free means you don't pay anything. I like that. But the thing about it is that it's open source. So when we talk about open source, it means that we can modify the operating system to best fit our needs. You can't do that with Windows. You can't do that with Mac OS. So you have sort of like an open cookbook that anyone can read, edit, and or use to improve the recipes. I have a Betty Crocker cookbook up there. It has a crab dip recipe. And it's awful. But I took that crab dip recipe and I made changes to it. And now the crab dip that I make is the best crab dip I've ever had. But it started with a really bad recipe in a Betty Crocker cookbook, believe it or not. So the operating system could be exactly the same way. You can modify it to best fit our needs. And so that's the reason why I have so many different versions of Linux. Now, the next thing about why Linux. Why do you need to know Linux? Why do you need to know your way around Linux, especially in IT? Well, it's everywhere. It's absolutely everywhere. You can find Linux in your Android phone. So if you have an Android phone, it's running Linux. Smart TVs, they run Linux. Okay? Supercomputers, they run Linux. And servers everywhere. This includes your Google, your Amazon, and Facebook servers. They're all running Linux. So every single day, you are already interacting with Linux-based systems. You might not realize it, but every time you open up your Gmail, you're working against a Linux-based operating system web service, right? Anytime you open up pretty much any sort of Amazon web page, Netflix, you name it, you're interacting with Linux-based software. Oh, it's everywhere. You deal with it every day. So if you want to learn how to build these tools and you want to learn how to actually deploy applications, you're going to need to know Linux. Finally, I don't know, is this finally? Yeah, finally, it's customizable. Now, I've already talked about this. It's open source. You can modify the operating system to best fit our needs, right? We could do that. But the thing is that with Linux, you can pretty much start with something called a distribution. Okay? And with distributions, what we're talking about are already modified and already customized and already configured versions of Linux that might fit your needs better than others. There are very popular ones. So, for example, you have Ubuntu, which is a very popular distribution of Linux. It's what we use in our learning environments, and it's perfect for beginners. My gosh. Because you're not dealing with some corporation's lingo or nonsense. You're dealing with something fairly open source, fairly basic, and it's a Debian-based operating system. But then you can get into some other stuff, such as Red Hat Enterprise Linux or SUSE Linux, where you can get into distributions like RHEL. And the reason why people like Red Hat Enterprise Linux, and I'll just type it out here, Red Hat Enterprise Linux, is because Red Hat has provided a number of tools to help out with things like security and operating that particular machine. They have a lot of tools and extended packages and ways of distributing software, Yum or DNF, for example, that a lot of corporations really, really like. Also, we need Red Hat Enterprise Linux, so that way our corporations can spend more money than they need to. But that's just my opinion. Point is, you can get Linux as freely as you want. Anyone can just install Debian or Red Hat Enterprise Linux. Then there's Mint and a bunch of other ones. Right? There are plenty of consumer-grade Linux products out there. Or, for those who are more enterprise-grade, enterprise level, and you're deploying something that we need to secure and lock down and take very seriously, you have other options like SUSE Linux or Red Hat Enterprise Linux, okay, that you can then use to install your applications and to further secure or better optimize the use of your machines. So it's really up to you. Personally, I prefer things that are very, very lightweight. I prefer to do things that are very much under my control without a lot of extra bells and whistles. So me personally, I'm a big Ubuntu fan as a result of that. So using Linux, we're going to talk about using Linux here in a little bit and why you should care about Linux. But really, just right off the bat, when it comes to the why Linux, these are the reasons. These are the well understood and documented reasons to why Linux. Now here's the Tim's version of why Linux. Okay? Here's my reasoning. Everyone needs to know Linux. Everyone needs to know Linux. I don't care who you are. We live in a world driven by computers. There are computers in your car. Those have operating systems. It's true. You have computers on your phone. You have a computer in your microwave or on your refrigerator these days. Those are driven by Linux-based operating systems. Many of them are. So something that you interact with on a day-to-day basis, not just one thing, but almost everything, is a computer. And just like how you should have basic working knowledge of how your car engine works, you should have basic working knowledge as to how your computer engine works. So we live in a world driven by computers. You need to have a basic understanding. There's a true story. I met with the attorney yesterday for our case with involving my daughter, and I met with him yesterday, and his email address caught me by surprise. It was an AOL.com email address. I told him I didn't know that existed anymore. But yes, he had an AOL.com email address. I thought that was wild. So how does this, how do you even function in this world? And he has basic struggles. Very, very sharp legal mind. But to get that man on computers ain't happening. And he struggles today. He's even said, hey, if I got computer issues, could I call you up? I'm like, yeah, man. I said, I'll tell you what. I'll tell you about my bill rate. I'm really expensive. That's what I told him. Oh man, I'm very expensive, but anytime you let me know, and I'll bill you. He goes, no problem. Well, you need to have a basic understanding, because the truth of the matter is that you're going to be driving computer-based software and solutions regardless of what your job is. If you're a crane operator, chances are there's a computer component to what it is that you're doing. When you throw a switch or a lever, right, there's a computer taking that input and doing something with it. You need to know this stuff. The next thing is, okay, typically, why Linux, you need to know command line interface. Okay? You need to know CLI. And the reason why you need to know CLI, I don't care if you're doing Windows OS CLI or Linux-based CLI, you need to know CLI. What that means is that we're going to need to know how to write commands into a command line. So what you're seeing right here on the screen, this is a command line interface. This is an operating system that gives me a command line, and I type in commands directly to the computer. Now, you're probably thinking to yourself, if you're somebody who isn't in the know or isn't used to working with computers at this level or to this degree, you're thinking to yourself, well, where is my mouse? I want my mouse. I want to click on different buttons that makes different things in Windows appear, and I can interact with my file system by way of Windows Explorer or something else. All right? And that feels so much more advanced, and that feels so much better, doesn't it? Because you have this neat little graphic, and you can see the mouse, and you can click, and things happen, and it's exciting. No. What you have done is you have now hired a third party to get between you and the machine. And the third party can only do certain things. And in order for you to do those certain things, you have to actually click on the right thing and go through their weird menu and then get here and then do that and do this. Whereas I could just tell the computer through a single command a very complicated function, and it will do it. And if that complicated function doesn't exist via the Windows operating system or whatever user interface with buttons and the clicky clicks that you like, if that functionality doesn't exist built in by those applications, guess what? You can't do the thing you want to do. When it comes to troubleshooting systems, and when it comes to actually building and actually running these systems, you need to have full unadulterated access to that machine, with nothing in between you and that machine. There is a very, very big problem where people have become reliant on the GUI-based user interface. I need my clickies. I need my buttons. I need my windows. I need my search bar. I need a video tutorial. I need this. And as a result, you're handicapping yourself. You're handicapping yourself. You are literally saying, I want less power in exchange for ease of use. Well, that's no good. We can't have that. That's not good at all. I don't want to give up power. I want full power. Unadulterated access to my machine. So you need to know CLI. You need to know command line interface. You've got to know it. And then finally, you need to be able to fix your own stuff. I have no problem saying this, okay? I cannot tell you how many times people go, oh, you know, computers, you can come by, you can fix my stuff. I ain't fixing your stuff for free. And I charge way too much. You can't afford my bill rate. Stop it. And you don't want to pay me to come over to your house to fix your computer. I'll charge you too much. Okay? Stop it. You need to be able to learn how to do this on your own. Okay? I don't know if you've been listening to the news lately, but a lot of people are making a big deal about the price of eggs for some reason. So with that being said, you could save yourself an awful lot of money with some really basic computer skills. And I mean the basic of the basic. Most of the times when you have a computer problem, when you're troubleshooting something on your own at home, you can solve it fairly quickly with very beginner knowledge in computing. Stuff that I deal with and stuff that I have to fix on a day-to-day basis is way more complicated than the regular consumer grade problems you would run into. So with that being said, I want to jump into Linux, and I want to go over some basic lab stuff with Linux, and we're going to learn some basic Linux commands. And we're going to get people started on Linux CLI. So let's do it. Let's do it. So here's what I'm going to do. Let's jump into the most important thing that I could teach you and I could show you. And I'm going to actually bring up some graphics that I use for a different class. So let's see here. Let's bring up hold on, I don't want that one. I want the other one. Let's bring up our Kubernetes course here. And I'm just going to take a look at the same slide that I actually showed yesterday. And this applies here. And what I was showing off yesterday was what is a container, what is a process. But the truth is that the most important lessons that we learn about computers is actually on this understanding of processes in general. Because you're going to look at the inner engine of what's actually happening. So most people know and understand that, hey, I've got a CPU, central processing unit, right? And what does that CPU do? Well, it makes calculations. It does math, basically. It makes calculations. And as a result of those calculations, we get an output. And the more processing units that you have and the faster that they are, right, the more calculations you can perform within a given period of time. That's your CPU. Then we have something called memory. Well, now that I've generated output, I have data. That output is data. If I don't have a place to store my calculations, then it's lost immediately. Yo, what's up, Kenneth? Good to see you. It's lost immediately. So I need to store the output of my calculation somewhere, and that's handled in memory. Now, there's a bunch of different types of memory, and we could talk about your required understanding. Everybody who's in computers, you do need to understand where memory goes, where it comes from, and how fast memory is depending upon where it comes from. Okay? But just know that as we are performing calculations, I need to store this somewhere. That's memory. So CPU memory, that's all you really need to think about right now in terms of hardware. Okay? If you're just joining us, good to see you, by the way, Ken. If you're just joining us, we're just getting into basic computing. We're going to like the basic of the basic. I'm saying let's start from ground zero, okay? As though you know nothing about computers. So you just got, if you just coming in and joining us, you missed a whole introduction about why Linux, what we need to learn Linux. The important thing is you do need to know Linux, and I'm going to teach you Linux right now. It's basic stuff. So we have memory. We have CPU. It's making calculations. Memory, we have to have a place to store the output, right, of our calculations. That makes sense. We have a file system. We need to have a place to actually save our files, right? And then mount points. Mount points could be something like a hard drive or a USB drive. It's a file system that we can then plug into a machine, and you can access other storage devices and mediums. So CD-ROM, DVD-ROM, right? Who uses those anymore, right? Typically our hard drives. Those are mount points. Or maybe I am accessing some external file system. I can add that as a mount or a mount point. So think of mount points as sort of like a hard drive or a disk drive or a USB drive, right? That's what we're talking about. Those are different mount points that exist out there. So you're familiar with that stuff. Well, the thing is that our software, in this case, our processes, okay, Our software needs to gain access to all of this different part of our computer, whether it's the physical resources of the central processing unit or the memory, or it's something that is in storage, a file system, and other various mount points like a CD-ROM drive, or maybe we're talking about something like networking where I need to have access to my VLAN switch or an actual network stack, right? And I want to make network connections with other machines. My applications, my software, we need to talk to these different things. But the thing is that my software cannot talk to CPU directly, nor can it talk to memory directly, nor can it talk to your file system directly, nor can it talk to your mount points directly. It can't talk to your network. It can't talk to anything directly. We need something that knows how to talk to this stuff. And that something that knows how to talk to this stuff, coffee talk, is a kernel. Call this the kernel. One of the most important reasons why you need to know Linux is because this Linux kernel is so powerful and so efficient and so easily customized and so easy to work with that without that Linux kernel, you're going to have trouble. So much so that Linux kernel is integrated with Windows operating system. Windows now uses a Linux-based kernel. And many of its operations, everyone is using this kernel. This is a thing that happens. Where did I learn? On the job and the Navy. And my family was a very techie family. So I learned from my dad and from my older brother. They taught me a lot about what I need to know in regards to computers. And then I had naval training, and then I was very much self-taught from there. So I had a very good foundation from my parents, and then the Navy, my older brother, and then self-taught from there. In case you're curious. I went to school for business administration. I went to college for business administration, so I didn't learn any IT from college. Which is the reason why I'm telling you, forget college. You don't need it. Drop out of school, kids. No. Shh. We'll talk about the best deal in tech training ever. Okay? We'll talk about it. I mentioned it at the top of the program. We'll mention it again here in a minute. Okay? But point is, okay, we need something that knows how to talk to all of your PC components, and that's the kernel. This is the clearinghouse for all input-output. So if my process needs to access some CPU in order to run calculations, it could do so, but it does so by way of the kernel. So if this process needs to run calculations, I'm going to use CPU resources, but I'm not going to go to those CPU resources directly. No. I'm going to go through the kernel, right? So this kernel is what's driving everything from inter-process communication, so one process talking to another, to a process that needs to access things like a network, to a process that needs to access something like a file system, our memory, our mount points. The kernel is what's running all of this. And this kernel is incredibly powerful. Tyler, welcome. We're doing a we're doing a full introduction. This is the beginner's class of beginner's class. If you knew nothing about computers and you wanted to learn about computers, this is what we're doing. I just went over why Linux, and now I'm explaining what the kernel does. So welcome to the show. So, continuing on. Now that we understand, okay, many people who've ever sat in front of a computer, okay, CPU, central processing unit, running calculations, memory, right? That's RAM, random access memory, or read-only memory. We could talk about ROM and RAM, right? Then we have file systems. That's basically like directory structures. You understand that. Mount points, hard drives, USB drives, that sort of thing. Networking, right? You have an IP address. Many people understand what an IP address is, right? We now know that the kernel is what actually attaches all of our processes, all of our software, all of this stuff, right? That kernel attaches all of this stuff to those other parts of our computer. So before we get on to Linux and Linux-based operating system operations, I want to remind you all very quickly, now that I have a few more people coming on in, about the best deal in online training ever. And this deal, you need to be made aware of it because it's cheap, and cheap is good. We like cheap. So let me go ahead and grab that link real fast. Where is it? There we go. Perfect. Let's bring this on over here. Let's get into Alta 3 Academy. This is the best place to now learn all things IT. It's the cheapest. It's the most content complete. It's the best in terms of overall instructors because, look, you guys are here. You're sitting with me. You're learning computers from me today, right? Okay. All of our instructors teach it at this high level. They're wonderful. They're great, okay? Come on by. Sit through a class. Or subscribe to Alta 3 Academy. What is Alta 3 Academy? I want to make this very quick, simple, and sweet, short. Okay, you ready? It's unlimited access to 14 on-demand courses. These are full courses. These aren't abridged. These aren't short. These aren't like little things. These are full courses, 14 courses that you get, that you can train at your own pace whenever you want to train, with real lab environments that you can provision at any moment. So it's all on demand. You say, I want to train today, you could provision for yourself an environment and get to work on labs right away. And are you ready for this? With all of that, you're going to get it for $3 for a 3-day trial. You got $3. Load it up. See what it's about. See if it's something you're interested in. You get 3 days of full access to Alta 3 Academy. 3 days. For a month, $40. For a year, $299. For anybody who's ever paid for IT training ever in their lives, $299 is about the price for a standard self-paced course that you have to complete within a limited period of time. We're giving you 14 courses and lab environments that you could use and access on demand for an entire year for $300. Real nice and easy. Super cheap. So if you like watching these podcasts that I'm doing and you want to play along, you want to run along with me, go sign up for Alta 3 Academy. Then you can provision your environments on demand whenever you want, and you can follow along with me and learn with me as we're doing these podcasts. And it's super cheap. Try it for free, $3. You get courses like Crush the RHCSA, Certified Kubernetes Administrator, Application Developer, CKA Mock Exam, CCAD Mock Exam, the Ansible Essentials, Python Essentials, Python 201, and Terraform Infrastructure's Code, as well as a few others. And here's the cool part. We're adding more courses over time. So it's 14 courses today. Tomorrow it could be, well, not tomorrow, but in the future it could be more. It will be more. We're going to be adding more courses as time goes on. This is the cheapest, best deal on the face of the planet. And we do train people like Amazon, Verizon, Cisco, Accenture, JP Morgan Chase. I have personally trained Verizon and Cisco, which is always a lot of fun. I think I've even done some of the Accenture stuff too. I actually did, and the AT&T. I taught all of these guys, except for I don't think I had any Amazon classes. I might have. I had Disney and Pixar. That was fun. Point being, okay, we teach the big guys. All right, we're a best kept secret. We don't want to be a best kept secret anymore. Come on in. Spend a little bit of money. Take a look at what we offer. Come out back for the podcast, and we could do cool stuff that's unique to the courses. I do my own thing here. Okay, I'm not locked into any of those courses. I do my own thing over here. So whatever I do, it doesn't necessarily have to be part of our courses. So you could do bonus stuff with me with this environment. It's really dope. So check it out. I'm going to go ahead and put a link here in the chat. This is the Alta 3 Academy. Literally the best training deal for IT on the market. You cannot get better. This is it. This is the best deal, period. Jump on in and get it done. All right. So let's continue on. We're doing basic computing, guys. We're going to learn this just purely the basics. So what we've learned so far, what we've covered so far is what is an operating system? And if you missed any of this, this video will be on demand. You can go back and watch the lesson from the beginning. And if you want to get caught up on, hey, what's an operating system? What's Linux? Why Linux, right? And all that good stuff, you could watch whenever you'd like. But what is an operating system? In short, just think of like an engine in your car. It's what drives the vehicle, right? Just compare to an engine in your car. It's what drives the vehicle. Why Linux? We talked about this, but in short, it's free. It's everywhere. And it's customizable. Okay, it's free, it's everywhere, and it's customizable. And then we went in and we discussed kernel, the kernel. Now, I didn't write any notes here, but here's what you need to know about the Linux kernel. The Linux kernel, okay, is the I/O clearinghouse of your operating system, okay? It's the interface between your processes or software. We'll say processes because we're entering the Linux world, okay? Your software is made up of a bunch of processes. So this is the interface between your software or the process I'll talk to you here in a second, Talirium. It's the interface between your processes and your computer components. That being things like CPU, memory, network. Okay. Titularium, you need to know and understand. Are you ready for this? Windows uses a Linux kernel. Yeah. Windows is becoming more and more Linux over time. It is slowly becoming Linux. It has become more Linux over time. So don't worry. If you're primarily in a Microsoft operating system which is Windows world, okay? Linux kernels are already involved in that, and that's just going to continue to increase. The Linux and Windows, they're going to need to start adopting more Linux kernel stuff in operations to keep up with the rest of the world. As far as what your company does, I don't know what your company does. There's plenty of people out there who live in a Windows operating system world, okay? That being said, I do think that those corporations are hamstringing themselves a little bit. That's my personal opinion, but what do I know? I don't know your software. I don't know your domain knowledge. I don't know what tools your company and its assets, i.e. its people, are bringing to the table. That being said, what you don't want to do, Tylerium, or anybody else in the IT world is, you don't want to turn a blind eye to Linux because, well, my company doesn't use that. Well, what happens when your company goes under? What happens when you get laid off by that company? What happens when you need to move for whatever reason? You can no longer work for that company. Just because your company might be stuck in the Stone Age doesn't mean you should be. Keep that in mind. And now that training is so cheap and so approachable, there's no reason not to learn it. We use Active Directory on Linux-based systems as well, which is wonderful. Gotcha. But now that trading is so cheap and easy to get, seriously, it's never been this cheap. Like guys, I don't. Anybody who's been a fan of my programming since the beginning, since 2015, I've been doing this for 10 years. You know I don't push product unless I like it. I'm really pushing this. One, I helped build it. Okay. But two, this is the bee's knees. You don't get a better deal than this. Period. So now that training is so easily accessible, and you can actually access this training, you're out of excuses. You got to learn this stuff. It's too easy. If you're in IT, you got to jump into it. So, with all that being said, that's the kernel. It's the interface between your processes and your computer components. Wonderful. So, again, your CPU, not CPS, CPU. You can tell where my mind has been, guys. Oh, boy. CPU, memory, network, right? That's our interface between all our computer components. But the next thing is that the kernel is also going to be an interface to something called a file system. And the next thing that we need to learn about Linux is the Linux file system. Because before we can begin building applications, before we can begin like writing our own code, we got to know the way around our box. We got to know the way around our machine's directory structure, where our files stored. The most important thing you got to learn about Linux is this. Okay, here it is. The most important thing you need to know about Linux. You ready for this? Everything in Linux is a file. Everything is a file. Commands. Mount points. Okay? Keys, certs. Output. Input. Error. Everything is a file. Everything's a file. And we access our files through something known as the POSIX file system. We use the POSIX file system. So, when we talk about a file systems, we're going to be talking about the POSIX file system. POSIX stands for, and this is what POSIX stands for, a portable operating system interface. That's POSIX. And what it does is it will define how files and directories should be structured in a Unix-like system. So that means Linux and Mac OS. So if you're used to Mac OS, POSIX, same thing. So some key characteristics. Guys, go ahead and screenshot this. I'm gonna disappear myself. Go ahead and screenshot this for your notes. Then I want to clear this off. We're going to get into what POSIX is. Awesome. All right, I'm back. Let's go ahead and let's clear this all out. I'm going to start with POSIX and then boom, boom. Boom. Excellent. Cool. That's how we are. So, key characteristics. Of a POSIX compliant File system. Yeah, you get off with VOD. Yeah, perfect. Yeah, that's what the VOD is for. So key characteristics of POSIX compliant file system. We already talked about one of them. Okay? One, everything is a file. Everything is a file. Regular files, directories, devices, and even processes. Even processes are a file. Everything is a file. We talked about containers the other day. Guess what? A container, when it's running, is a file. It's a file. Everything is a file. Okay, number two. Everything is built in a hierarchical structure. So files are organized in a tree-like structure. So, for example, I could run the command tree. And you could see all of the files and directories that are in my home directory. It's a tree. It's all hierarchical. There it all is. Okay? So I just run an application called tree. Boom. It shows me the hierarchy of all of my files. Okay? Excellent. I have 13 directories and 14 files. Wonderful. Let's clear that out. Let's get everything back up there again. We're getting there. All right, cool. We're there. All right, next up. The next thing you need to know and understand is that everything is permissions and ownership driven. So you have permissions and ownership. Every file has an owner, a group, and specific permissions. For reading, writing, and executing. Okay? So every file has an owner. And every file has a group. That group could just simply be the owner again, by the way. Every owner has their own group. And then you have specific permissions for reading, writing, and executing. Reading means I can open the file and I can look at it. So imagine opening up a document like a text file. I want to read this thing, so I open it for reading. Writing means that I can open a file and then begin editing that file. So maybe there is a file that someone was working on, and I have permissions, because I belong to their group, to write over that file. So I can make changes and edit it. And then executing, what that means is let's say, for example, that file is an executable, meaning it's an application, it's a process. I can run it. So if I have executing or exec privilege, that means I can run the script of the application that that file is representing. Wonderful. So there's permissions and ownership, and we'll talk more about that as we go on. Now, we have a standard API. What? Yeah, we have a standard API. Now, what does that mean? Well, we have the ability to provide functions. So we can provide functions like open, read, write, and close for file handling. Right? This is a standard API for Linux. So that way, no matter how you customize it, no matter where you get it from, we're all using the same functions, whether it's Red Hat Enterprise or it's Ubuntu or Debian. These are standard APIs. So when I'm hooking up my application or I'm writing code for my application, we know that these functions will always be there, and we can utilize these functions accordingly. So that makes it very easy for us to build applications that can work against a number of different operating systems that are Linux-based. Then we have something called symbolic and hard links. You might have heard someone use a term like symlink, for example. POSIX allows both types of links to connect files. Essentially, a symlink or hard link, you can make either or, enables me to make a file that simply links to another file. Think of it as like a shortcut. A shortcut is like a symbolic link to a file. Okay? So we have the ability to do that. So think of it as like shortcuts. Then finally, case sensitivity. And this is important to know, and it's shocking to me how few people know this who've been in this world. And this is like one of the easiest things to know. File names are case sensitive. So for example, file.txt and file.txt with different casing are different files. They're different. Casing is important anywhere in Linux. Anywhere in Linux, casing is important. You need to know and understand casing and spacing, especially when you're playing around with things like, say, for example, you're playing around with Kubernetes manifests or YAML. Depending on the interpreter, casing is very important. And if you don't use the appropriate casing, you'll get a syntax error. That is because of the fact that the file system itself, the POSIX file system, is case sensitive. So if I want to call a command, well, what's a command, everybody? The answer is on the screen right now. If I were to say, what's a command, what is it? If I were to call a command, I want to call a command, what is it? What is anything in a POSIX-based file system? Everything in Linux is a, say it with me. Come on now. Don't let me down here, chat. It's a file. That's it. Yes, we did it together. Yes, it's a file. Everything in Linux is a file. So if a command is a file, and you're trying to call a particular command, and you decide to use the inappropriate casing for that command, guess what you're going to get? You're going to get a syntax error. Because a command is a file. So everything is case sensitive. You have to pay attention to your casing when you're dealing with a POSIX-based file system. It's very important. So I have, guys, this is the Kubernetes Coffee and Games podcast. Every once in a while, I'll relate something to what's happening in my life because that's what we're all here for. We're all here to help me with free therapy. Okay? So point being, is that I like having an interactive audience. And I've noticed that I have a 2-year-old. In the house right now who is in love, fully enamored with this TV show called Miss Rachel on Netflix. And Miss Rachel is always trying to get the audience to finish her sentences or to come up with the answer or to tell you what color something is or for you to guess what's in the box. Which What's in the Box episode was great because the entire time I was screaming, "What's in the box?" Okay, the whole time I was screaming, "What's in the box?" And of course, my 2-year-old has no clue why I'm so excited by that. It's the first episode of Miss Rachel. Check it out. But I'm like, that is an appropriate teaching style Fill in the blank, guys. What's the answer? I love it. I love it. Anyways, just asking, what is it? What is it? What is a command, everybody? It is a file. Command is a file. Everything is a file. That is it. It's perfect. Miss Rachel's great, by the way. Fully recommend Miss Rachel if you have a little, all right? If you have like a little preschool, little kid, oh my gosh. Miss Rachel is just killer. Fantastic preschool programming. Check it out. All right, everybody. So those are the 6 key characteristics of a POSIX compliant file system. So now that we understand that we have a POSIX compliant file system, the next thing that we're going to have to do, oh boy, is figure out what's going on when we install Linux for the first time. What is coming packaged in that Linux operating system file system thing? Tyler, tell them you're learning. No. No, let's get in here. So that's the next thing we're going to do. Okay, so let's go ahead and screenshot this. I want to get rid of this. I'll give you all an opportunity to take a picture of this. These are the notes. Yes, I want to make sure people are paying attention and not lost. Very important. I'll tell you one thing. I do like doing the podcast format of teaching way better than a formal class, because in a formal class, there's no way I'm talking about Miss Rachel, and there's no way I'm making, like, connections to gaming or anything. All the jokes, I keep many of them, but there's plenty of times I have to stop myself. So many times I have to stop myself. Hold on, I shouldn't make that joke. Anyways, let's keep going. So, now that we understand all of this, the next thing we have to understand is that since we are dealing with a hierarchical structure or hierarchy of files, there is one file to rule them all. Before we get into that one file to rule them all, remember, there are 2 types of files. All right, you have a standard file, and then you have a directory. Now, standard files can be broken up into many other types as well. Like you have an executable file, for example, and then you have file extensions, right? So understand that there's a lot of different types of files out there. But just in terms of just like the most basic of basic, you have directories, which are files. Everything in Linux is a file. And then you have like your standard files, okay? Your executables, your text files, your YAML files, your different code, right? Okay, perfect. All right. So now that we understand that, we have one file to rule them all, and that one file to rule them all, the one file to rule them all is a directory. It's a directory. And it's known as the root directory. Root. Is simply /. Ah. It's the parent of your entire computer. It's the beginning. Root is the alpha and the omega of your computer. Okay? Okay. Because after all, we begin from somewhere. If you were to liken this to an actual tree, the root would be the seed, the place of origin where it all began. The root directory is the top-level directory of the file system. In short, everything starts here. Everything starts there. It's the beginning. So, we need to change directory to root. Let's try it. Let's do cd /. CD stands for change directory. This is the first command that I'm putting in to the machine with you all. So if you're following along from Alta 3 Academy and you've got yourself an environment like I have been asking you to do, you should be able to type in cd change directory / That is change directory to the root directory. And there we are. You'll notice that our prompt has changed. We'll talk about this. This tilde that you see here in our prompt represents the home directory. We'll talk about the home directory later. This is now /, meaning we're in the root directory. Yes, Deep Squid, earlier, you should have said that it's the / of it all. Perfect. Perfect. Yes. Excellent. So we're now in the root directory. Let's go ahead and clear this out. I'm going to type ls. This basically means to list the contents of my directory. Before I type ls, I want to teach a few other Linux commands. Okay? So pwd stands for present working directory. When you use that command, pwd, you're going to get back an output that tells you where you are currently at in the POSIX file system. I'm currently at the root directory. Okay? cd, that stands for changed directory. So you saw me earlier, cd /, that changes my directory to root as an example. Okay? And then the next thing that we're going to need to know is ls. Basically, it means to list. We're just listing the directory contents. So this is going to give me a list of all of the files that are in my present working directory. So we'll type ls, and there you go. These are all the files. I just listed all of the files that are in my present working directory. And this is probably some of the most boring stuff I could teach about Linux, is POSIX. So if we have found a way to make it interesting or somewhat approachable, yay! If you find yourself kind of getting lost in the sauce, not like Tanky Sauce, he never got lost. But if you're lost in the sauce, it's okay. That was a throwback. It's okay. Just be aware that all of this stuff might seem very, very complicated. Oh, I'm never going to remember all of this. Oh, my gosh. Oh, gee, this is awful. I'm so silly. I don't know what's going on. This is way over my head. If you have that feeling right now, I want you to understand something. There are people who have been doing this for decades. Decades of experience. Who cannot tell you what the bin directory is and what's in it. Or what the op directory is and what's in it. Because you're here getting the fundamental of the fundamentals, okay? You're going to get this stuff. Rewatch this. Commit this to memory. You're going to have a leg up on a lot of different administrators because of this. Not a lot of people get this type of fundamental instruction. We don't even provide this type of fundamental instruction because we have to teach you a bunch of stuff within a certain period of time. I don't have time to dig into this nitty-gritty stuff. I don't when I'm teaching a formal class. A lot of people, they don't ever get this. Not to this level. Okay? So, if it feels over your head, if it feels complicated, just remember in the back of your mind, most people don't know what this is. You have a leg up because you're getting this introduction. So let's keep going. All right? Don't give up on me. Let's do this. So, we got a bunch of directories here. We're going to go over what each and every single one of these directories do. Remember how I told you that everything is a file, right? Including commands? Those commands live in a directory called bin, B-I-N. So let's change directory into bin. Here I am, I'm in bin, and let's ls, And there we go. We got ourselves a bunch of files. So these files are all executables. You notice that they're green. And they're executables because these files are commands. Oh. These files are commands. So for example, I'm going to use the power of tmux. We could teach tmux later, but I'm going to cheat a little bit. I'm going to scroll on up. And we're going to go look for CD. Let's go all the way up, see if we can find CD. Ooh, there's CP. All the way up to CD. CH, CC, CD should be here somewhere. Should be here. I was expecting to see that. I see that we have cat. That's a command that we use all the time. Where's CD? Might be stored somewhere else. Probably is stored somewhere else. But there's cat, and that's what I want to show you. Cat is a very, very normal command to run. We run cat all the time. Cat stands for concatenate. Okay? And we're going to go ahead and we're going to run that command cat. I'm going to use cat to concatenate the cat file. Cat basically just means show me the contents of the file. Show me what's written to that file. So I'm going to cat. And what we get back is a lot of gobbledygook. But we just catted cat. We also get back some things like some man page stuff, which is really interesting. But all in all, we use the cat command to cat the cat file. That's fun. We catted cat. This is where your commands will live. This is where your executables and other things like that will live here. So, for example, you might find Python is here as well. That's what the bin directory is for. Let's go back. Let's go back to root. Ooh, that was fancy. What did I do there? This right here says go back one directory. I want to go to the directory that's the parent of my present working directory. .. / means take me back one. That happens to be root. Would have been the same thing if I just did cd space / would have taken me to the same place. Okay? Next thing we're going to do is we're going to change directory into the boot directory. This contains bootloader files. So things like grub or VM linuz. Here, there's grub. There's VM linuz. In any particular case, these are bootloader files. So these are files that are involved in actually initializing your machine once it boots. So we can make changes to how your machine boots by taking a look at grub, for example. Here you see we have a grub.cfg. If I were to cat grub.cfg, oh, wait. Don't worry about me, guys. You'll see that we have a configuration file. This talks about different conditionals, if-then conditionals, even some bash scripts in here in order how to guide how we end up booting our operating system. There's a lot of stuff in here. All right. Now, there's ways in which we can customize this and change this, change the way in which we boot our operating system, our machine, right? But this tells us not to edit the file. It is automatically generated by grub mkconfig using templates. Ooh, so now you could see how we would actually make changes to this file. You would make changes to this file by going to etc grub.d or etc default grub. But this is the actual file that's controlling it, but you shouldn't edit this file. No. You're going to edit grub.d, etc grub.d, or etc default grub. That's the file you would actually edit. But this is where the actual grub CFG file is. So everything that we need as far as loading or booting up our machine can be found in the boot directory. That's exactly what that's for. Let's go ahead and let's do something fancy. I'm going to go back one directory, but then I want to go forward a directory, and I want to change directory, and I want to go to dev next. I could do that. cd /dev will take me to the dev directory. Wonderful. I'm now in the dev directory. Now, dev does not stand for develop, as you might think, but rather it stands for device. This is the device directory. So this is device files representing hardware. So remember how I told you everything is a file. That includes hardware. So for example, SDA for disks, or TTY for terminals. So if we were to ls, you would notice that we got a lot of device files in here. These TTYs are device files for terminals. You see CD-ROM in here, disk. These are all device files. So if you have a device, a hardware device connected to your machine, it will appear here as a file. Everything is a file, including your devices. Next up, let's go ahead and let's change directory to Etsy. Now this time I'm just going to use /Etsy. That will take me to the Etsy directory. That's another way in which we could use CD or change directory. I could just specify the full file path that I'm interested in getting to. So I just did CD Etsy. That'll take me straight to Etsy. Wonderful. Now Etsy is one of those files or one of those directories whose naming isn't really helpful. Etsy doesn't really tell me what it is. I just think of etc., 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 right? Well, that's terrible because that doesn't help us at all. So what is Etsy? Etsy is the place that we store system-wide configuration files. System-wide configuration files. So this is something that we would set up things like passwd, passwords for users, or something like hosts for networking. But Etsy is where we would find our system-wide configuration files. You might recall that grub in the boot directory was saying, hey, make changes to the Etsy grub.d file. That's where my configurations are stored. And this file will be edited according to a template based on what you put into etcd, or Etsy grub.d. I had a little too much Kubernetes on the brain. All right. So with that being said, I should be able to ls this content. Here we go. And you'll see that we have a whole bunch of configuration files in here. Any configuration file, if you know it's something, it's a file that's going to be configuring something. Here's grub.d, by the way. It's more than likely going to be in the Etsy directory. That's where you could find it. So, for example, if you were sitting in one of my Kubernetes classes and we're doing CKA, I might tell you that you need to go to the Etsy Kubernetes manifests etcd.yaml file in order to configure your etcd. That's located in the Etsy directory of a control plane node. Etsy should be synonymous in your mind with config or configuration. That's what the Etsy directory is for. All right, cool. Well, what's next then? Well, let's go back. We'll go back our fancy way, and we'll come into the home directory. Now, wait a minute. What's in the home directory? Well, here's student. You might have noticed, based on my prompt, that I am the student user. I'm student. When I'm accessing this machine, I am the student user. That is me. I have my own directory. Let's cd into that directory. I'll type cd space student / and now you'll notice something. What has been traditionally our present working directory as part of our bash prompt here is not just a tilde. Tilde is equivalent to my home directory. I'm the student user. I am now in my student home directory. That's what that tilde means. And these are all my files. Okay? If I type in pwd, you'll see that I am in the home student directory. So if I were to change directory to the root directory, I could change directory to my home directory just by typing cd space tilde. That'll take me back to my home directory. I can also go back to my root directory, and now let's just type in cd. cd nothing else will take you to your home directory. That cd nothing else will take us to our home directory. There it is. So there's a couple other ways that you could use the change directory command. Neat little shortcuts. Okay? In the home directory is going to be the personal files of the users. So these are personal files, configurations, and settings. So typically one thing you would find in a home directory, we're going to learn something new about ls, or I want to list the contents of my present working directory, right? Tag A, show me all the files, including the hidden files. Ooh, the home directory is home to a lot of hidden files. And the reason why is because me as an individual user, the way that I approach using applications might be different than how somebody else approaches their applications. So I'll have my own configurations. I'll have my own configurations with my own stuff happening. Cool. I like that. So these configurations are stored as hidden files in my home directory. So that way I can make changes to my personal configurations without impacting other users. So these are different than global configurations, which is what you would find in the Etsy directory, because these configurations only pertain to me and me alone. And those are the hidden files and directories that you can find in your home directory. Neat. Let's keep going. Let's go back to the root directory. And next up, we're going to hit up the lib directory. A cd into lib or lib. I say lib or lib. Most people say lib. I occasionally say lib because I know that it's short for libraries. More specifically, it is short for shared libraries. These are needed for system binaries and dynamically linked programs. Okay. You also have a lib64. That's for your 64-bit programs. Okay. So you have that as well. That's where you can find shared libraries. Next up, we have the media directory. The media directory is the mount point for external storage devices. So those are your USB drives or DVDs. So anytime I mount an external storage device, thus giving me a whole new file system to play around with, that's going to show up here under media. So USB drives, DVDs, that sort of thing. The next is the mount directory. Right now it's empty. And the reason why is because the mount directory is the temporary mount point for manually mounted file systems. So say, for example, I decide that I am going to mount an NFS or a network file system to my machine. Basically, there's an NFS server out there that has its own file system, its own storage, its own files, right? And I want to mount that to my machine. I want to gain access to those files. When I create a connection to that NFS service, it is going to connect and attach itself to my mount directory. I'll be able to find that NFS storage system here under mount because I have manually mounted that file system. So it's the temporary mount point where I can find it. It's /MNT. Next up, let's get into the opt directory. The opt directory is for optional software and third-party applications. So, for example, you might find something like Google Chrome installed here or other proprietary software. So if you download something that's commercial off the shelf and you install it, chances are it's going to put some of that application into the opt directory. As for optional software, not system software, optional software. Next up, we have proc. Proc is the virtual file system providing system and process info. So, for example, you might find something like proc CPU info. Let's take a look at that. So if we do an ls here, you'll see that we get all sorts of stuff back, including CPU info. Let's cat CPU info. And you could read the contents of that file. There it is. As you can see, it just contains key value pairs giving us information about our CPU. So this is an Intel Xeon CPU E5 2680 V3 at 2.5 gigahertz. Cool, right? It's a genuine Intel, everybody. Genuine. It's the genuine article. It's the real deal, guys. But there you have it. All right, so that's some CPU information. So proc, again, is the virtual file system providing system and process information. Now, I heard that you all like the root directory. I heard you all like the root directory so much that I put a root directory in your root directory so you could root directory while you root directory. Yes, there is a directory called root. That isn't just the root directory, it's the root directory. What? Uh-oh. I have permission denied when I try changing directory into the root directory. Why is that? Well, think about it this way. You know how me as the student user, I have a directory. It's my home student directory because I am the student user. So if root has a root directory, then you would be correct in assuming, well, then there must be a root user. And if the root directory is the one directory, the one file to rule them all, then couldn't you also rationalize and reason that the root user is the most powerful user on your machine? Yes. Now, the student user on this machine has the power to become root. And we're going to do just that. I'm going to use a command, sudo. That stands for super user do. I did attack I. Basically, I've just said, hey, make me become root. You can do a sudo su. Become the super user, for example, is another way you could do that. We like using sudo tech I. That maintains all of my wonderful bash prompt and all the other settings that I currently have while still making myself the root user. So that's a really nice, elegant way of doing that. But you'll notice now that I no longer have student on the left side of my bash prompt, but now instead I have root. I am now the root user. And now that I am the root user, I have full and complete control over this machine. It's mine. That means that I can also access file systems that would ordinarily not be accessible to me. In this particular case, root / the root directory root. Just to make sure that's very clear as to what directory we are in / root. Okay? This is the root user's home directory. So if there are files that I want the root user to own, I would put it here. Let's stay as the root directory, as the root user for a little bit. We'll continue being root. We have a couple more to take a look at. We have run, snap, and var. Now, there's a few other root directories that we'll talk about that are not included here, okay? So let's get into the next one. The next one is going to be run. So run, or what run is simply the temporary system info files. So temporary system information files. Well, what does that mean? Well, remember how processes are files? Yeah. Process IDs. These are process IDs. So if I do an ls here, you'll see a few things that should be very, very interesting to you. These are all different processes or directories to processes that are currently running. The most important directory in here, the most important one is systemd. If I cd into systemd, ls in here, these are all of the systemd services that are currently running. So journal, for example, inhibit, system, users, unit root, units, shutdown, all of these are different services that are running. And this is where we can find those temporary system information files. The next up is sbin. So if bin is binary, what would sbin be? Anybody want to take a stab at it? What would sbin be? I think Deep Squid, I think you just typed admin. Which you're on the right track. I'll take that. Because these are files that are typically used by the root user. So these are fdisk, right? But what we call that S is actually system. That S stands for system binaries. So we're dealing with system binaries here. So these are files that are typically used by the root user. Shutdown, for example, is here. Okay. But any files that I don't want a random run-of-the-mill user to use, but rather I only want the root user to be able to run these, that is where this will go. It goes into the system binaries, okay? And these are all of the system binaries that are here, like AppArmor, for example, is here, add user, delete user. These are all root functions or root commands. So they live here in sbin. Think of it as like super binaries. If you want to think of another way of the S, as opposed to system binaries, you know, have super binaries. That would be great. Great way to think of that. Now, Let's get back to the root directory, and let's list the directory contents. You will notice that we do not have a /srv directory. This is a directory that is used on systems that have services like web servers and FTP servers. So you'll find /serve on systems for web servers. So it's data for web servers. So for example, you'll see serve /HTTP and FTP servers. Okay. So we don't have that in our learning environment. No need for us to have it. Next thing that you'll notice here is sys. We don't have that either. This would be a virtual file system for kernel interactions. So there will be a virtual file system for kernel interactions. In our particular case, we don't have one. That's perfectly fine. Then there is temp, TMP. Temp stands for temporary directory. These are temporary files that are cleared on reboot. So they'll go away. And then finally, var. We'll change directory into var. You can see the contents here. But var stands for variable data, like logs. So you'll oftentimes see var log being used. And these are databases, mail, and spool directories. So for example, you see mail here. So this is variable data. It could change depending upon what's happening. So typically var lib, var log, that's the sort of thing that you could see running here. We would use var log all the time to take a look at system logs and the like in order to see how our machine is running. So that's what the var directory is for. So now we've had the time to go through the incredibly dry and boring discussion as to what is in the root directory. So let's go ahead and let's discuss a few key takeaways. First, I'm going to exit out of the root user. I don't want to be root anymore. Next, I'm going to return to my home directory. So the key takeaways here. If I forgot everything else, what do I need to know from this? Linux follows a POSIX compliant hierarchical system starting from the root directory. Starting from the root directory. So everything begins at root. That's a really fancy way of saying everything begins at root. Everything begins at root. In this particular case, Ubuntu, which is what we're learning from today, organizes system files logically across directories. Really, it's pretty much any Linux-based operating system. And then finally, understanding the structure is crucial for systems administrators and troubleshooting. If I'm troubleshooting a file system, I need to know where that file system is. Right? Where can I find it? If I need to do configurations, I'm dealing with a user configuration, I need to know where to find it. That'd be in my user's home directory, ls tac a. Tac is dash in my language. Okay? And that'll show me all of the hidden files and directories in my home directory, and I can find my configuration file there. If I'm dealing with a global configuration, I know I need to go to the etc directory. If I'm looking for variable data, like log files, I need to go to the var directory. If I'm looking for my USB thumb drive, I need to go to the media directory. Okay? So we need to know where to look. Those are your key takeaways. Any questions about this? All right, excellent. Excellent. Cool. I could dig it. So, here's the deal. I can't do these podcasts every day. To quote somebody in the multiverse, whoa, this is heavy. There's a lot to learn. Well, this is just the beginning. This is just the tip of the iceberg, guys. Just the tip of the iceberg. But once you understand these fundamentals and then begin to apply these fundamentals, man, there's so much you could do. And people pay you big bucks to do these things. Now, before you think AI is taking away these jobs, it's not. It's not. These jobs will always require a human being involved. Always. That being said, these jobs are getting more complicated. That's certainly true. But you can remove a lot of that complexity by having a good, solid foundation. Because if you can remember some of the key points that we learned today, that Linux is an operating system. It's what drives your computer, okay? That it has a POSIX-based file system. That everything in Linux is a file. And that the kernel is what connects processes to things like hardware and your file system and mount points. And you can recall a few details about which directory is which, what does what. You're building upon a solid foundation. Now you can expand upon that solid foundation by heading on over to the Alta 3 Academy website I'm going to put down in the chat. And I'm going to push this because here's the deal. I mean this from the bottom of my heart. If you want to learn IT, or you're looking to make a change, and you want to learn IT, and you want to have a new career path, or something like that in your life, you want to expand your skills, and you want to learn more, take a look at Alta 3 Academy. This is your all-access pass to DevOps Mastery. DevOps and DevOps management, that's what I'm into, right? Being a DevOps engineer is really cool. You build systems. You build and configure systems. And you do it idempotently and automatically. The world runs off of DevOps. And if you want to run the world, you got to know DevOps. But we could teach you DevOps and DevOps topics from beginning to end. Everything you need to know. And you can get certified off of our courses as well. So you get unlimited access to all of our on-demand courses. You could train at your own pace. You get your own hands-on lab environment. Same lab environment I'm using, you can get. And it's really easy to try. $3, $3, guys, to try this. $3. And you'll get full access to everything. Don't like it? You won't even miss your $3. Okay? This is almost so cheap that Atomic Atrox could almost afford this. Atomic, if you're here, I love you. All right, if you don't want to pay the $3 to try this, I'll spot you the $3. Okay? Point is, there's no excuse. There used to be an excuse. Training was expensive. Training was expensive. Training was expensive. Not anymore, guys. $3, you can get 3 days of training for $3. After that, monthly $39 a month, annually $299 a year. And I'm going to be teaching out of this environment during our Kubernetes Coffee and Games podcast. And we'll be teaching all this stuff. We'll be teaching all this stuff. You can follow along with me. Maybe you're taking some of the classes. You have a question. You can hit me up. I'll answer that question. Okay? Because I teach all these classes. This is a really good deal. It's a really good deal. All right, I got one more thing for you before we break for lunch. And when we come back, I'm probably going to play Baldur's Gate 3. We'll play after lunch. But I got one more thing I want to talk about before we break for lunch, and that is the GoFundMe, which I am very thankful. We had a donation from a Tyler Young. Much love to you. Much love to you for another $20. So much appreciations to you. Thank you so much for that. This is a very important GoFundMe. Appreciate you, Tyler. I wasn't going to name drop you like that. No, dude, don't. Just spread the word, man. Tell your stream about it. That would be the biggest thing. And even if no one from your stream contributes to this, just them knowing that this is a thing that's happening in the world is important to me. Oh, good. I appreciate that, Tellerium. Thank you. But just knowing that this is a thing that's happening in the world, that's something that I think people need to be aware of. And the big thing here is that we have a situation in which children who are in foster care system, they're supposed to have attorneys, they're supposed to have lawyers to help protect their best interests and to have their voices heard. In the state of West Virginia, for every 200 children in care, there's only one guardian ad litem. There's no way that those 200 kids to one guardian ad litem are getting the appropriate representation that they deserve. It is impossible for one individual to manage that type of caseload. It is impossible. They cannot do it. Not only that, but the state doesn't pay a very good rate for those children. So oftentimes an attorney might be assigned cases, but they're less interested in working those cases because the billable time on those cases is significantly less than their other cases. And so what ends up happening is that you have a situation much like what's going on with our daughter, where she requires representation to protect her rights. Her rights are being infringed upon, and she's being put into dangerous situations, and no one is advocating for her properly, and she's stuck. That's a very bad place to be. I'm not going to read the whole thing again, but I am going to tell you that she does need your help, and we need to be able to fund a lawyer for her to represent her. And in order for her to have her wishes known. And her wish right now is for Tanantha and I to be her mom and dad, to be the ones in charge of her healthcare decisions, for her to maintain contact with us even at this point. Because even that has been taken away from her without reason. And it's against her rights. She has a right to maintain contact with her previous caregivers, and that right is not being honored for her at the moment. So as a result, we have a problem. And she needs representation to protect her rights. So thank you so much for taking the time to hear a little bit of this story. And if you want to learn more about it, I'm going to post a link here down into the chat. And not only that, but you could find a link in the description down below. If you're watching the VOD of this, you could find it there. But in any particular case, guys, thank you so much for just hearing about this story and considering supporting and giving to this child who is in desperate need of help. She needs representation. She wants court intervention. One of the last things that she told us is that she wanted me to tell the judge that I'm her dad. That was literally the last thing that she and I talked about the last time we had a chance to talk. So I'm going to do everything in my power to do just that. We're going to go tell the judge that she wants me to be her dad. And your help is man, that's a big thing to say. Oh, I'm almost tearing up thinking about it. In any particular case, that's the situation. Thank you so much for just hearing that story. And I appreciate you all so much for the help that you have given us towards this goal already. We hit our initial goal, which is about 50% of what we expected all to cost. We expected to cost a little bit more than what we asked for, twice more than what we asked for originally. We're prepared to hit the other 50%, but that's coming out of different funds for things like computer labs and the whole nine. So your current contributions is going to reduce a lot of that pain. We would like to take our kids on the same trips we're planning on taking them. We'd like to get them the computer lab going and things like that. But In order for me to help this young lady come home to us, I will definitely pull from that fund if I have to. I'd rather not, but I will if I have to. In any particular case, guys, thank you so much for tuning in. Big shout out once again to Alta 3 Research for sponsoring this. Guys, sign up for Alta 3 Academy. It is literally the best deal on the market for learning. Jump on it, guys. Jump on it. Thank you all so much for hanging out with me. I'll see you all later and next time. Until then, I'll see you back in like an hour or two. We're gonna play Baldur's Gate. I think we're gonna play Baldur's Gate. I want to play Baldur's Gate again. So that's what we're going to do. We're going to jump on and play some Baldur's Gate this afternoon. I'll see y'all back here in a little bit. Enjoy your afternoon, and I'll see you for Digital Recess. I think we're going to keep coffee, Kubernetes, coffee, and games to just tech stuff and talking, and we'll talk games too. But the actual playing of the game we'll call Digital Recess, and I think that's what we're going to do. So come back for Digital Recess this afternoon. We're going to play some Baldur's Gate 3. Until then, y'all, have a good one. Ta-ta and TTFN. It's ta-ta for now.